Alright, here we go. Third time doing this. We have our polynomial 2x to the third minus 6x squared minus 18x plus 5. We're going to find the derivative of that, which f of 1x is 6x squared minus 12x minus 18. We're going to look for our critical points to put that to equal to 0. So we now have our 3 critical points, which is 3, negative 1, and 0. Now we're going to put that on our line, and we're going to find points around that we can test to see if it's an increasing, decreasing, or not, or what was the other one? Neutral interval? I forgot the third name. Either way, we're going to put it into our test, so we find it's a 30, positive, negative 18, negative 30. So you know it's an increasing interval that we'll show later on the Desmos graph. Now, we're going to take a second derivative of our first derivative, which is 12x minus 12, and that is equal to 0. X is equal to 0 there. Similarly, we're going to put it on another line and find points around it, which I chose negative 2 and 1, respectively. And f second to negative 2 and 1 are negative 36 and 0. From that, we can determine our point of inflection. And we know that our concavity down is negative infinity 0, and concavity up is 0 to infinity. Now to check for our limits when they approach infinity and negative infinity, we're going to take the start of the polynomial, which is 2x3. And when x approaches infinity, when it's 2x3, we know it's infinity. And opposite, when x approaches negative infinity, it'll be negative infinity. Now, to find the relative max and relative min, we're going to take the second derivative and plug in our critical numbers, which are 3 and negative 1. So you see here we have negative 1 and 3. We plug it in, we get negative 24 and 24. We know our relative max is x is negative 1. Relative min is x is equal to 3. Now to show you the graphs, here we go. Have a negative 1 and 3 there. First derivative. And our second derivative. Here's all of them together.